Page 8 of differentiation rules. Number 4. Given f of x equals e to the kx plus x, and the derivative at x equals 0 is -8, find k. So this is kind of a backwards problem, right? They put an unknown here. It's a number. We don't know what it is. And then they tell us what the derivative value is at a certain number. Okay, so even if you have doubts about how to do this problem, you know that to find the derivative of this original function, even if it has k here, you can still do it, right? Just pretend it's a number. So the derivative of e to the kx, first you just rewrite the exact same expression, and then you multiply that times the derivative of the exponent kx. The derivative of kx, if k is just a number, is k, right? The derivative of 3x is 3. Derivative of 10x is 10. Derivative of kx is k. And then the derivative of x is just 1. So there's our derivative function. Now we also use the fact that x is equal to 0 and the derivative is equal to -8 at a certain point. So we can substitute those in. We could put -8 here, and we could put 0 in for x. And then we can use algebra to solve for k, because e to the k0 is e to the 0. E to the 0 is 1. So we have -8 equals k plus 1. So k is equal to -8 minus 1, or -9. So our original function was actually f of x equal e to the -9 k plus, e to the -9 x plus x. So k was -9. 5a. By substituting e to the natural log of 2 for 2 in y to the 2x, find dy dx. Okay, so this is looking at a situation where we look at this function and it doesn't look like anything we know to take the derivative of. If it was an exponential function with e as a base, then we know that the derivative of e to the x is e to the x. But if it's 2 to the x, it kind of looks like e to the x, but it's different, right? So what they're saying is, as a workaround, you can substitute e to the natural log of 2 for 2, and that'll help you. Is e to the natural log of 2 the same thing as 2? Yes, because e and natural log cancel each other out, so it's actually equal to 2. Let's see how that helps us. So instead of 2 to the x, we're going to write e to the natural log of 2 to the x. Then I'm going to rewrite that as, let's see, e to the natural log of 2 times x. And now I'm going to take the derivative of this. Now remember, the natural log of 2 is just a number. So when you take the derivative of e to the natural log of 2 times x, it's you just rewrite the exact same function. And then you multiply that times the derivative of the exponent, which is natural log of 2 times x. The derivative of natural log of 2 times x is natural log of 2. It's just a number. So if it was e to the 3x, the derivative of 3x would be 3. If it's e to the natural log of 2x, the derivative of natural log of 2x is natural log of 2. There's one more simplification we can do, right? Because remember, we rewrote 2 to the x as e to the natural log of 2 times x, right? And here we have it again. So we can replace this back with 2 to the x if we need to. So we could write this as 2 to the x times natural log of 2, okay? Now for b, it says, if you have the function y equals b to the x, where b is greater than 0 and b is not 1, then the derivative of b to the x is this. You can kind of see we did that for b equals 2, right? So let's try to do that for y equals b to the x. So the first thing we need to do is we need to rewrite the base b as e to the natural log of b, right? So we're going to substitute e to the natural log of b in for b. And then we're going to group the natural log of b with the x. And then we're going to take the derivative of it. So we're going to rewrite the exponential, and then we're going to multiply it times the derivative of the exponent. And then we can replace this back with b to the x because they're equivalent. And we're done. Okay. 15F, derivative of log functions. Okay, so from the investigation, we found out that the natural log of x, the derivative of natural log of x is 1 over x. Using the chain rule, write down the derivative of natural log of f of x. So if we have a function inside of a function, then we know that the derivative is going to be 1 over the inside function multiplied times the derivative of the function. So this is our chain rule for natural log. Okay, recall the laws of logarithms, which can facilitate differentiation. So remember, the natural log of AB is equal to the natural log of A plus the natural log of B. Natural log of A divided by B is natural log of A minus natural log of B. Natural log of A to the n is equal to n natural log of A. Find the gradient function of natural log of 7x. So this is a function inside of a function. We're going to do chain rule. First thing we're going to do is we're going to do derivative of the outside natural log. So we would just put 1 over the inside function. And then we would multiply times the derivative of the inside function. Weird, the derivative of natural log of 7x is the same derivative of natural log of x. Okay. C, derivative of a function inside of a function. So first thing we're going to do is we're going to write 1 over the inside function. And then we're going to multiply times the derivative of the inside function, which is 1 minus 2x. If we simplify that, we'll write 1 minus 2x over x minus x squared. Next one. Ooh, it is a product. So if this is u and this is v, then u equals x squared. U dash is equal to 2x. V equals natural log of x. V dash equals 1 over x. We're going to use product rule. We're going to multiply those together and those together. X squared times 1 over x plus natural log of x times 2x. Let's simplify that. X squared over x is x plus 2x natural log of x. Okay. Derivative of e to the x times natural log of x. This is a product also. U is equal to e to the x. U dash is equal to e to the x also, because the derivative of e to the x is just e to the x. Derivative of natural log, hold on a second. V is equal to natural log of x. The derivative of natural log of x is 1 over x. The product, so we're going to multiply these together and these together. E to the x over x plus e to the x natural log of x. Done. Derivative of y equals the square root of natural log of x. I'm just going to rewrite this as natural log of x on the inside and to the 1/2 power on the outside. A little easier to do power rule then. First, we take the derivative of the outside function. Something to the 1/2 is 1/2 of something to the negative 1/2. Then we do the chain rule of the inside function, 1 over x. Done. So I don't think there's much to simplify here. We could group the two denominators together. Actually, everything's practically in the denominator. 2x is in the denominator. Natural log of x to the 1/2 is in the denominator. If you think that's easier, we could rewrite it like that. K equals y equals square root of x times natural log of 2x. This is a product again. This is u. This is v. So u is equal to x to the 1/2. V is equal to natural log of 2x. Derivative of u is 1/2 x to the negative 1/2. Derivative of natural log of 2x is 1 over the inside function times the derivative of the inside function. which becomes 1 over x, which is also the derivative of natural log of x. Again, weird. Okay, now I can do product rule. So I'm going to multiply this times this, and I multiply this times this. So x to the 1/2 over x plus 1/2 x to the negative 1/2 times natural log of 2x. Maybe the only thing you might want to simplify is this. It would be x to the negative 1/2, right? Okay. And m. Derivative of 3 minus 4 times natural log of 1 minus x. Derivative of 3 is 0. Not equals. I'm taking the derivative. Derivative of negative 4 natural log of 1 minus x. Negative 4 is a coefficient. You just let it lie. Derivative of natural log of 1 minus x is 1 over the inside function. Derivative of the inside function, y minus x, is negative 1, because the derivative of negative x is negative 1. Derivative of 1 is 0. Right? So 0 minus negative 4 times negative 1, positive 4, over 1 minus x. Done. Find the dy dx for y equals x times natural log of 5. Now, when you look at this, you might think, oh, it's product rule. I got a u, I got a v, but remember, natural log of 5 is just a number. So it's just a coefficient. So basically, this is not a natural log problem. You have natural log of 5, which is just a number. Maybe it's like 1.5 or something, times x. What's the derivative of a number times x? The number. That's the answer. Natural log of 5. Done. Y equals natural log of x to the 4th plus 4. So this is a function inside of a function. First thing you're going to do is you're going to take 1 over the inside function. And then you're going to multiply times the derivative of the inside function, which is 4x cubed plus 1. Simplifying, 4x cubed plus 1 over x to the 4th plus 4. Done. That's it.